question is asking, given a 2 input 1 output RBF network with 2 RBF senders at T1 is equal to 0 0 and T2 is equal to 1 0 with 2 weights W1 and W2 and 1 bias W0, 4 input vectors x1, x2, x3, x4, and x1 is 0 0, x2 is 0 0.9, x3 is 1 0, x4 is 1 0.9, with the corresponding desired output vectors d1 0 0 0, and the Gaussian function consisting of the I2 norm operator is used as the radial basis function. So the step-by-step calculation to obtain the combined weight W0, W1, W2 to recall the 4 corresponding outputs y1, y2, y3, y4 and submit the sum of 3 weight values as your answer rounded to 4 decimal places. Hint, a minimum resolution of 6 decimal places per step-by-step calculation is required. Okay, so finally we had to calculate this combined weight vector, combined weights. Let's see how to do this. So this is the method. Like first we are grabbing this T1 and T2 which is provided to us, and then 4 points x1, x2, x3, x4 is also provided to us. In this instance, we will demonstrate how to create generalized RBF network to solve the XOR problem by utilizing 2 RBF sender and 1 bias rather than the 4 RBF sender typically needed in the interpolation RBF network. The kth output of the generalized RBF network can be expressed as using Gaussian function. Y of xk becomes y of xk is equal to summation p is equal to 1 to 2 wp phi xk minus tp plus p, and that is also equivalent to y of xk summation of p is equal to 1 to 2 wp exponential minus xk minus tp square plus b. Okay. Gaussian function consists of squared I2 norm operator as the non-linear function. A pair of Gaussian function is defined as g of xk minus tp is equal to exponential minus x1 minus t1 square for k is equal to 1, 2, 3, 4 and p is equal to 1, 2, where 2 RBF centers are represented by tp, p is equal to 1, 2, t1 and t2. Repeating the above procedures, the entries of the G can be obtained as these are the entries we obtain. We use that equation that we looked here. Okay, we calculate individually for everything using this. And G11, as you see in the equation, exponential minus x1 minus t1. So that's one for the G11. Like if it's 1, 1, you see x1 and t1. If it's 1, 2, you see x1 and t2. If it's 2, 1, you see x2 and t1. 2, 2, x2 and t2. 3, 1, x3 and t1. Like that, you place the x and t values and then calculate the values. You have to put the values and then square them and then square them and the exponential of that. And once you calculate this one, the first one is 1 and all these values you get, and then you have to put it in a matrix like this: G11, G21, G31, G41, G12, G1, G22, G32, G42. I already obtained the values. I place it accordingly like this order and define the combined vector as WC, W0, W1, W2 transform. The following matrix equation can be obtained by WC is equal to H plus D, where H plus represents pseudo inverse of the matrix H, which is defined as H plus, which is equal to H transform times H inverse times H transform, and D is equal to 1, 0, 0 transform. Now from G, combined matrix H can be expressed as, we had to just grab this exact same thing and put 1 in front of each like this. Okay. So we will get a 4 by 3 matrix like this. And once we got this, the rest of them can be easily calculated using Matlab. And this is the Matlab code. First we define the matrix H, the bias term with Gaussian outputs. This is exactly what we have right here. We put it in matrix in Matlab, and then define the desired output D, that is D is equal to 1 0 0 0, and calculate the pseudo inverse as we see in the pseudo inverse equation right here. H plus is the pseudo inverse of matrix H, and that is nothing but H transform times H inverse times the H transform. Okay, that is right here. And then calculate the weight, which is W is equal to H plus times D, as we look right here. And then set the format to long to display more decimal places, because the question is asking us to minimum 6 decimal places. That's why we use this long, because if you don't use it, you're gonna end up having like 4 decimal places, but we need 6 or more, so that's why I use this long. And once we do that, we sum and calculate the values, and this is what the output will give. We have all 3 matrix will be provided, and then we have to sum them together, and we will end up getting this, and the final answer should be 4 decimal places. So I round it to 4 decimals, 0.9162, and this is my final answer. And the Matlab code, if you want to try the Matlab code, I go to the Matlab. Okay. Okay, here I try my Matlab. I hope you can see that. So here we go. I run a maybe I create a new script. Okay, so this is the code right here, the exact code I saw here. And you had to just run the code, that's it. Like, it's gonna provide the values. Run, and as you can see in this window right here, I'm getting all these 3 weight vectors, and then we add them together and finally get the sum of W, which is 0.916. And that's how we do this kind of problems. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.